Hi, welcome to example 2 of proving triangles congruent. Remember that we start out with a skeleton flowchart, and in the skeleton we talk about this large rectangle is talking about 3 corresponding parts that are congruent of one triangle, and it's got to be the right combination of corresponding parts. And then it produces 2 congruent triangles, and then we can use that to prove that other parts are congruent. Now, in this particular one, we need to extend the skeleton in both directions, and you'll see why in a minute. But that's not uncommon. But we take a look at our diagram here, and we want to first analyze the diagram. And that's why we're making the flowchart proof, just so we can, again, organize our thoughts. And so it says that segment WX is parallel to segment TP, and that segment WX is also congruent to segment TP. So right away we have a congruency of segments, but we need more than one segment. We also see that in the 2 triangles that appear to be congruent, we have vertical angles here at A. Angle WAX and angle TAP are going to be congruent because vertical angles are congruent. Any angle in a pair of vertical angles are congruent. So now we need to get another thing congruent that would be from the information given. Well, hopefully you recall that when you have parallel lines, it produces some congruent angles. That if 2 lines are parallel and they're cut by a third line, or transversal, that the angle at W here and the angle at T, they're called alternate interior angles, and they happen to be congruent if the lines are parallel, and in fact they are. So we know that angle W and angle T are congruent as well. So we have the angle, if you take a look just at the triangle WAX, we have the angle at W, the angle at A, and the side WX. And that would be AAS or SAA. Okay, angle, side. And so the reason why we're going to have triangles congruent here is because of angle, side. Now, the thing we have to prove though is that WT bisects PX. Well, now you got to know what bisect means. Bisects means that it makes it so that the 2 pieces on either side are the same length. So if we can show that XA and PA are the same length, then that would mean WT bisects XP. And of course, we know that if the triangles are congruent, then the corresponding parts are congruent, which would be XA and PA. And so therefore, A would be the midpoint. A is exactly the same distance from P as it is from X. And so that's what we put down in here. So we know we're going to have, if we look carefully, we know we're going to have angle W, angle W is going to be congruent to angle T, and we know that angle WAX, I'm just going to rewrite copy this here, that angle WAX is going to be congruent to angle TAP because of vertical angles, And we know that that Wx is congruent to TP, because that's given. And that's going to be our three things. It's going to be AAS. Now the thing is that while we know this, we have to say how we figured this out. And so the reason why we could say this is true is because they're alternate interior angles. Which was given. And the reason why I know this is true is because they're vertical angles. Which I just abbreviated as vert. And of course we know this is true because it was given. And so we have the three things that are congruent and the three reasons why they're congruent. So therefore we can say the triangles are congruent. Say triangle WAX. That got pretty big there, didn't it? Is congruent to triangle. That would be TAP. And of course the reason for that, which we can write underneath here, is would be AAS. Now it doesn't matter if you write AAS or SAA, they both mean the same thing. And then finally, over here, we can say that XA and PA are the same. Well, it shouldn't say finally because we're not quite done yet. Here we have to then add a line, you know, something like this, and say, well, that means that WT bisects PX. Ran off the page here. Well, I should have had more room here, but it bisects PX because, of course, definition bisect. And that, of course, is definition. So I'll write that here. Now it'd just be definition. And that's really the proof. So to recap that, we have parallel lines, which technically I suppose we could type in over here further. We would say something like, you know, WX is parallel to TP. I'll do that here. Oh. WX parallel to TP, and that was given information, so I could write given down here. And that way, somebody wouldn't wonder, well, where did you get that from? Because a given is given. So we'd set it with this, and of course, since the lines are parallel, then the alternate angles are congruent, which would be the second half of the statement here. So this is given, lines are parallel, therefore alternate angles are congruent. we know that these are congruent because vertical angles given, and that's whole proof. So we put a little bit before this box because we weren't given the congruency statements, we were given parallel, so we had to get from parallel to congruent, and this is a congruency box. And we ended up having to go beyond CPCTC because we needed to prove not particular parts. I mean, it could just as easily have said prove XA is congruent to PA, and then we'd be done right here. But because it said prove that there's a bisector, then we had to go one more step and say it bisects.